Okay, well, let's take a look at this problem. We have a piecewise function, and we have to find the value of k if the function is continuous at 2. Well, we can see that one piece is equivalent to 2, and then the other piece does not equal 2. So which condition of continuity do we need to examine? Well, we need to examine the third condition that says the value at 2 must be equivalent to the limit as x approaches 2 of this function. And the reason why we're looking at this condition, this is actually the third condition, is because we know that the value at 2 is going to be k plus 3. And if we can find the limit at 2, then we'll be able to solve for k. So what is going to be the limit of 2 at 2? Well, the limit, remember, doesn't mean the value at 2. It means what value am I approaching as x gets closer to 2. So if I investigate this, and if I look at the numerator is going to be 2x plus 5, minus square root of x plus 7, which when I do that, 2 times 2 is 4, 4 plus 5 is 9, square root of 9 is 3. I actually get 3 minus 3, so I get 0. And then when I look at the denominator as x approaches 2 of f of x, which is, actually I should just write the denominator, which is k plus 3. Oh no, x minus 2, I'm sorry you guys. X minus 2. 2 minus 2 is 0. So we notice then that we have the indeterminate form. So because I have indeterminate, I need to do some little bit more algebraic manipulation. So with the radicals, I'm going to go ahead and rewrite the original problem, and I am going to look at this and multiply by the conjugate. So the conjugate would be the square root of 2x plus 5 plus the square root of x plus 7 all over the square root of 2x plus 5 plus the square root of x plus 7. Okay, and so when doing this, then we're going to simplify the numerator and denominator. We multiply the first terms and we'll get 2x plus 5. We know that the middle terms will reduce out because it's a difference of two squares. And then when I multiply the last term, it's going to be subtracting, be careful, the quantity x plus 7. And in the denominator, I have x minus 2 multiplied by the square root of 2x plus 5 plus the square root of x plus 7. Okay, so I'm going to continue working this, and notice I keep writing the limit as x approaches 2 because I have not substituted that value in yet. Well, in the numerator, I get x minus 2, which is very convenient because we'll see that that factor then reduces out. Okay, so x minus 2's reduce out. Notice I rewrite the limit as x approaches 2 because I have not substituted the value in yet. Now I'm going to substitute the value and get the answer for the limit. So we know that 2 times 2 is 4, 4 plus 5 is 9, square root of 9 is 3, plus 2 plus 7 is 9, square root of 9 is 3. So I end up with the limit is 1/6. So now I'm going to go right back up here. And so k plus 3 must be equivalent to 1/6. So then I will get k. So it's a negative 3, subtracting 3 plus, so it's going to be a negative 2 and 5/6. Woo! That was some serious algebra there, folks.